So we're continuing looking at multiplying and dividing rational expressions. We're working on division now. So we're going to divide these rational expressions. In order to do that, though, we need to multiply by the reciprocal of the second expression here. So our first expression will be the same, and then we'll take the reciprocal of our second fraction. So when we multiply, we're going to want to factor as we go. I kind of do it in one step here. So x plus 11 can't factor. The second numerator, the x squared plus 2x minus 3, that will factor to become x plus 3, x minus 1. In our denominator, that 4x is going to stay by itself. And then we can factor a 2 from the right denominator. We'll end up with x plus 3. So when we look about what things are canceling, those x plus 3's are going to go away, and that's about it. So in the numerator, we'll have x plus 11 times x minus 1, and the denominator then will end up with 8x. Now, when we look for excluded values, there's two places we have to look essentially. We have to look at where the excluded values down here, as well as what would be the excluded values here, which is actually what's up here in the numerator now. So thinking about those excluded values, in the denominator here, x can't be 0. It also can't be -3. And then in this piece that is now in the numerator, we'll get the additional piece of x can't be 1. So number 5 here, we're going to change this to a multiplication. So we're going to multiply by the reciprocal, x squared minus 15x plus 56 over 5x squared minus 40x. So now we factor as we multiply. So the 20 doesn't factor at all. X squared minus 15x plus 56 factors to x minus 8, x minus 7. X squared minus 7x we can factor out an x. We'll be left with x minus 7. And then the 5x squared minus 40x we can factor out a 5x. We're left with x minus 8. So when we look at things that are canceling, x minus 8s are canceling, x minus 7s are canceling. So we'll end up with 20 over 5x squared. And we can actually simplify that a little bit. 20 over 5 is 4 over x squared. So when we think about our excluded values, we want to think about everything that's in the denominator now, as well as what was in the denominator here, which is now the piece in the numerator here. So x can't be 0, it also can't be 7, and it can't be 8. So nothing really additional here since those 7s and 8s are the ones that are canceling anyways. So those are the excluded values. So we're going to talk just briefly here about closure is and why these are closed as a function. So a set of numbers is said to be closed or to have closure under a given operation if the result of the operation on any two numbers in the set is also in the set. So when you think about these different groups, whole numbers, that's representing 1, 2, 3, any whole number. Integers, now we can include the negatives. So -1, -2, 1, 2, 3. And then rational numbers is any other numbers, so that's including decimals and stuff like that. So whole numbers are closed under addition. If I add two numbers, it's going to be another whole number. They're not closed under subtraction. Since whole numbers does not include negatives, if I did something like 2 minus 1, that's now belonging, that answer is, sorry, not 2 minus 1, 1 minus 2. If I take 1 minus 2, that's got an answer of -1. Well, now we've moved into the integers, and it's no longer in the whole numbers. So that one's not closed there. Multiplication is closed. If I multiply 1 times 2, I'm going to get another whole number. And division, it's not closed. So something like 5 over 2, it's going to give me a decimal. We're not a whole number anymore. Integers. Integers are closed under addition. They are closed under subtraction because it's okay now that we have the negatives. They're closed under multiplication, but they're similarly to the whole numbers, they're not closed under division. So same idea as before. If you take 5/2 or negative 5/2, you're now getting into decimals, which are rationals. And so in that case, rational numbers are closed under all of these things. So if we want to use a rational model, so a real-world problem, so models involving rational expressions can be solved using the same steps to multiply or divide. So they're giving us some information here, and you can look through this example on your own. It kind of walks you through it as needed. We're going to work through the next example, though, together. So the fuel efficiency of Tanaka's car at highway speeds is 35 miles per gallon. That is her efficiency. The expression 48E minus 216 over E times the quantity E minus 6 represents the total gas consumed in gallons when Tanaka drives 36 miles on a highway and 12 miles in a town to get to her relative's house. And the expression E represents the fuel efficiency in miles per gallon. If Tanaka's in miles per gallon of Tanaka's car at highway speeds, use the expression to find the average rate of gas consumed on her trip. So the total distance traveled is going to be 48 miles. She did 36 miles on the highway and 12 miles in the town. So we want to find an expression for the average rate of gas consumed on her trip. So to find gas consumed, we have to take gas consumed divided by the distance traveled. So we have that equation that's representing the gas consumed divided by the distance traveled, 48. So since we're dividing by 48, it's the same as multiplying by the reciprocal, which is 1/48. So if we do that, we'll end up with a 48 here now in the denominator. So we can solve for G. And then the value of E is 35. It tells you in the first sentence the fuel efficiency is 35 miles per gallon. So we can solve for G by substituting in the value of E. So we plug in 35 anytime we see an E. And doing that algebra there, plugging it into your calculator, you should get 1464 divided by 48,720. So when you divide, you get about 0.03. So the average rate of gas consumed is about 0.03 gallons per mile of